Matrices. Introduction. The evolution of concept of matrices is the result of an attempt to obtain compact and simple methods of solving system of linear equations. Matrices are not only used as a representation of the coefficients in system of linear equation, but also in certain branches of sciences, genetics, economics, sociology, modern psychology, and industrial management. In this chapter, we shall find it interesting to become acquainted with the fundamentals of matrix and matrix algebra.
Matrix. Suppose we wish to express the information that Radha has 15 notebooks. We may express it as 15 with the understanding that the number inside the bracket is the number of notebooks that Radha had. Now, if we have to express that Radha has 15 notebooks and 6 pens, we may express it as 15, 6 with the understanding that the first number inside the bracket is the number of notebooks while the other one is the number of pens possessed by Radha. Let us now suppose that we wish to express the information of possession of notebooks and pens by Radha and her two friends Fizia and Simran, which is as follows. Now, this could be arranged in the tabular form as follows. Which can be expressed as shown. In the first arrangement, the entries in the first column represent the number of notebooks possessed by Radha, Fizia and Simran, respectively, and the entries in the second column represent the number of pens possessed by Radha, Fizia and Simran, respectively. Similarly, in the second arrangement, the entries in the first row represent the number of notebooks possessed by Radha, Fizia and Simran, respectively. The entries in the second row represent the number of pens possessed by Radha, Fizia and Simran, respectively. An arrangement or display of the above kind is called a matrix. Formally, we define matrix as
Definition. A matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called the elements or the entries of the matrix. We denote matrices by capital letters. The following are some examples of matrices.
In the given examples, the horizontal lines of elements are said to be constitute rows of matrix and the vertical lines of element are said to be constitute columns of matrix. Thus, A has 3 rows and 2 columns, B has 3 rows and 3 columns, while C has 2 rows and 3 columns.
Order of a matrix. A matrix having m rows and n columns is called a matrix of order m cross n, or simply m cross n matrix, read as an m by n matrix. So, referring to the above examples of matrices, we have A as 3 cross 2 matrix, B as 3 cross 3 matrix, and C as 2 cross 3 matrix. We observe that A has 3 cross 2 is equal to 6 elements, B and C have 9 and 6 elements respectively.
In general, an M into N matrix has the following rectangular array, or A is equal to Aij M into N, where 1 is lesser than or equal to I is lesser than or equal to M, and 1 is lesser than or equal to J and lesser than or equal to N, where I, J belongs to N. Thus, the ith row consists of the elements AI1, AI2, AI3 up to AIN, while the jth column consists of the elements A1j, A2j, A3j, up to amj. In general, aij is an element lying in the ith row and jth column. We can also call it as I, jth element of A. The number of elements in an m into n matrix will be equal to mn. We can also represent any point x, y in a plane by a matrix column or row as x, y or x, y. For example, point P 0, 1 as a matrix representation any be given as P is equal to 0, 1 or 0, 1. Observe that in this way we can also express the vertices of a closed rectilinear figure in the form of a matrix. For example, consider a quadrilateral ABCD with vertices A 1, 0, B 3, 2, C 1, 3 and D minus 1, 2. Thus, matrices can be used as representation of vertices of geometrical figures in a plane as shown. Example: if a matrix has 8 elements, what are the possible orders it can have? Solution: we know that if a matrix is of order m into n, it has mn elements. Thus, to find all possible orders of a matrix with 8 elements, we will find all ordered pairs of natural numbers whose product is 8. Thus, all possible ordered pairs are 1, 8, 8, 1, 4, 2 and 2, 4. Hence, possible orders are 1 into 8, 8 into 1, 4 into 2 and 2 into 4. Example: construct a 3 into 2 matrix whose elements are given by Aij is equal to 1 by 2 into modulus of I minus 3j. Solution: in general, a 3 into 2 matrix is given by A is equal to matrix A11, A12, A21, A22, A31 and A32. Now, Aij is equal to 1 by 2 into modulus of I minus 3j, where I is equal to 1, 2 and 3 and j is equal to 1 and 2. Therefore, we get A11 is equal to 1, A12 is equal to 5 by 2, A21 is equal to 1 by 2, A22 is equal to 2 and A31 is equal to 0, A32 is equal to 3 by 2. Hence, the required matrix is given by A is equal to 1, 5 by 2, 1 by 2, 2, 0, 3 by 2.
Types of matrices. In this section, we shall discuss different types of matrices. 1. Column matrix. A matrix is said to be a column matrix if it has only one column. In general, A is a column matrix of order m cross 1. Row matrix. A matrix is said to be a row matrix if it has only one row. In general, B is a row matrix of order 1 cross n. Square matrix. A matrix in which the number of rows is equal to the number of columns, it is said to be a square matrix. Thus, an m cross n matrix is said to be a square matrix if m is equal to n and is known as a square matrix of order n. Diagonal matrix. A square matrix B is equal to Bij m into m is said to be a diagonal matrix if all its non-diagonal elements are 0. That is, a matrix B is equal to Bij m into m is said to be a diagonal matrix if Bij is equal to 0 when I not equal to j. Scalar matrix. A diagonal matrix is said to be a scalar matrix if its diagonal elements are equal. That is, a square matrix B is equal to Bij n into n is said to be a scalar matrix if Bij is equal to 0 when I not equal to j. Bij is equal to k when I equal to j for some constant k. Identity matrix. A square matrix in which elements in the diagonal are all 1 and the rest are all 0 is called an identity matrix. In other words, the square matrix A is equal to Aij n into n is an identity matrix. We denote the identity matrix of order n by In. When order is clear from the context, we simply write it as I. Zero matrix. A matrix is said to be zero matrix or null matrix if all its elements are zero. We denote zero matrix by O. Its order will be clear from the context. Equality of matrices. Two matrices A is equal to Aij and B is equal to Bij are said to be equal if they are of the same order. 2. Each element of A is equal to the corresponding element of B. That is, Aij is equal to Bij for all I and j.
Operation on matrices. In this section, we shall introduce certain operations on matrices, namely addition of matrices, multiplication of matrix by a scalar, difference on multiplication of matrices.
Addition of matrices.
Suppose Gopal has two factories at places A and B. Each factory produces sport shoes for boys and girls in three different price categories labeled 1, 2 and 3. The quantities produced by each factory are represented as matrices given below. Suppose Gopal wants to know the total production of sports shoes in each price category, then the total production in category 1 is for boys 80 plus 90, for girls 60 plus 50. In category 2, for boys 75 plus 70, for girls 65 plus 55. In category 3, for boys 90 plus 75, for girls 85 plus 75. This can be represented in the matrix form as shown. The new matrix is the sum of the above two matrices. We observe that the sum of two matrices is a matrix obtained by adding the corresponding elements of the given matrices. Furthermore, the two matrices have to be of the same order. Thus, if A is equal to A11, A12, A13, A21, A22, A23 is a 2 into 3 matrix and B is equal to B11, B12, B13, B21, B22, B23 is another 2 into 3 matrix. Then we define A plus B is equal to A11 plus B11, A12 plus B12, A13 plus B13, A21 plus B21, A22 plus B22, A23 plus B23. In general, if A is equal to Aij and B is equal to Bij or two matrices of the same order, say M into N, then the sum of the two matrices A and B is defined as a matrix C is equal to Cij M into N, where Cij is equal to Aij plus Bij for all possible values of I and j.
Example, given A equal to root 3, 1, minus 1, 2, 3, 0 and B equal to 2, root 5, 1, minus 2, 3, 1 by 2. Find A plus B. Solution. Since A, B are the same order 2 into 3. Therefore, addition of A and B is defined. R is given by A plus B equal to 2 plus root 3, 1 plus root 5, 1 minus 1, 2 minus 2, 3 plus 3, 0 plus 1 by 2 equal to 2 plus root 3, 1 plus root 5, 0, 0, 6, 1 by 2.
Multiplication of a matrix by scalar. Now, suppose that Fatima has doubled the production at a factory A in all categories. Previously, quantities in standard units produced by factory A were as follows. Revised quantities produced by factory A are as given below. This can be represented in the matrix form as shown. We observe that the new matrix is obtained by multiplying each element of the previous matrix by 2.
Example, in general, we may define multiplication of a matrix by a scalar as follows. If A is equal to Aij, M into N is a matrix and K is a scalar, then Ka is another matrix which is obtained by multiplying each element of A by the scalar K. In other words, Ka is equal to K into Aij M into N is equal to K into Aij M into N. That is, I, jth element of Ka is Kaij for all possible values of I and j. For example, if A is equal to 3, 1, 1.5, root 5, 7, minus 3, 2, 0, 5, then 3A is equal to 3 into matrix 3, 1, 1.5, root 5, 7, minus 3, 2, 0, 5 is equal to 9, 3, 4.5, 3 root 5, 21, minus 9, 6, 0, 15.
Negative of a matrix. The negative of a matrix is denoted by minus A. We define minus A is equal to minus 1 into A. Differences of matrices. If A is equal to matrix of Aij and B is equal to matrix of Bij, are two matrices of the same order M cross N, then difference A minus B is defined as a matrix D equal to of matrix Dij, where Dij is equal to Aij minus Bij for all value of I and j. In other words, D is equal to A minus B is equal to A plus minus 1 into B. That is the sum of the matrix A and the matrix minus B.
Example, if A is equal to 1, 2, 3, 2, 3, 1 and B is equal to 3, minus 1, 3, minus 1, 0, 2. Then find 2A minus B. Solution. We have 2A minus B is equal to 2 into 1, 2, 3, 2, 3, 1 minus matrix 3, minus 1, 3, minus 1, 0, 2 is equal to matrix 2, 4, 6, 4, 6, 2 plus matrix minus 3, 1, minus 3, 1, 0, minus 2. From the above, we get 2A minus B is equal to matrix minus 1, 5, 3, 5, 6, 0.
Properties of matrix addition. The addition of matrices satisfy the following properties. Commutative law. If A is equal to matrix Aij, B is equal to matrix Bij are matrices of the same order, say M cross N, then A plus B is equal to B plus A. Associative law for any three matrices. A is equal to matrix of Aij, B is equal to matrix of Bij, C is equal to matrix of Cij of the same order. Say M cross N, comma, A plus B the whole plus C is equal to A plus B plus C the whole. Existence of additive identity. Let A is equal to matrix of Aij be an M cross N matrix and O be an M cross N zero matrix. Then A plus O is equal to O plus A is equal to A. In other words, O is the additive identity for matrix addition, the existence of additive inverse. Let A, matrix of Aij M cross N, be any matrix, then we have another matrix as minus A is equal to matrix of minus Aij M cross N, such that A plus minus A is equal to minus A plus A is equal to 0. So, minus A is the additive inverse of A or negative of A.
Example. If A is equal to 8, 0, 4 minus 2, 3, 6 and B is equal to 2 minus 2, 4, 2, minus 5, 1. Then find the matrix X such that 2A plus 3X is equal to 5B. Solution. We have 2A plus 3X is equal to 5B, or 2A plus 3X minus 2A is equal to 5B minus 2A, or 2A minus 2A plus 3X is equal to 5B minus 2A. Matrix addition is commutative, or O plus 3X is equal to 5B minus 2A. Minus 2A is the additive inverse of 2A, or 3X is equal to 5B minus 2A. O is the additive identity, or X is equal to 1 by 3 into 5B minus 2A, or X is equal to 1 by 3 into 5 into matrix 2 minus 2, 4, 2, minus 5, 1, minus 2 into matrix 8, 0, 4, minus 2, 3, 6 is equal to 1 by 3 into matrix 10, minus 10, 20, 10, minus 25, 5 plus matrix minus 16, 0, minus 8, 4, minus 6, minus 12. From the above, we get matrix X is equal to matrix minus 2, minus 10 by 3, 4, 14 by 3, minus 31 by 3, minus 7 by 3.
Example. Two farmers, Ram Kishan and Gurcharan Singh, cultivates only 3 varieties of rice, namely Basmati, Permal and Naura. The sale in rupee of these varieties of rice by both the farmers in the month of September and October are given by the following matrices A and B as shown. 1. Find the combined sales in September and October for each farmer in each variety. 2. Find the decrease in sales from September to October. 3. If both farmers receive 2% profit on gross sales, compute the profit for each farmer and for each variety sold in October. Solution. 1. Combined sales in September and October for each farmer in each variety is given below. 2. Change in sales from September to October is given below. 3. 2% of B equal to 2 by 100 into B equal to 0.02 into B. Thus, we can see in October, Ramkishan receives rupees 100, rupees 200 and rupees 120 as profit in the sale of each variety of rice respectively, and Gurucharan Singh receives profit of rupees 400, rupees 200 and rupees 200 in the sale of each variety of rice respectively.
Multiplication of matrices. For multiplication of two matrices A and B, the number of columns in A should be equal to the number of rows in B. Furthermore, for getting the elements of the product matrix, we take rows of A and columns of B, multiply them element-wise, and take the sum.
The product of two matrices A and B is defined if the number of columns of A is equal to the number of rows of B. Let A is equal to Aij be an M into N matrix and B is equal to Bj K of B and N into P matrix. Then the product of the matrices A and B is the matrix C of order M into P. To get the I, kth element Cik of the matrix C, we take the ith row of A and kth column of B, multiply them element-wise and take the sum of all these products. In other words, if A is equal to Aij M into N, B is equal to Bj K of N into P, then the ith row of A is Ai1, Ai2 up to Ain and the kth column of B is B1k, B2k up to Bnk, then Cik is equal to Ai1 into B1k plus Ai2 into B2k plus A3i into B3k up to Ain into Bnk is equal to sigma j is equal to 1 to n Aij into Bjk. The matrix C is equal to Cik M into P is the product of A and B. For example, if C is equal to matrix 1, minus 1, 2, 0, 3, 4 and D is equal to matrix 2, 7, minus 1, 1, 5, minus 4. Then the product CD is defined and is given by CD is equal to matrix 1, minus 1, 2, 0, 3, 4 into matrix 2, 7, minus 1, 1, 5, minus 4. This is a 2 into 2 matrix in which each entry is the sum of the products across some row of C with the corresponding entries down some column of D. Find AB if A is equal to matrix 6, 9, 2, 3 and B is equal to matrix 2, 6, 0, 7, 9, 8. Solution. The matrix A has two columns which is equal to the number of rows of B. Hence, AB is defined. Now, A is equal to matrix 6 into 2 plus 9 into 7, 6 into 6 plus 9 into 9, 6 into 0 plus 9 into 8, 2 into 2 plus 3 into 7, 2 into 6 plus 3 into 9, 2 into 0 plus 3 into 8 is equal to matrix 12 plus 63, 36 plus 81, 0 plus 72, 4 plus 21, 12 plus 27, 0 plus 24 is equal to matrix 75, 117, 72, 25, 39, 24.
Non-commutativity of multiplication of matrices. Now, we shall see by an example that even if AB and BA are both defined, it is not necessary that AB is equal to BA.
These four computations are as follows. Note, this does not mean that AB not equal to BA for every pair of matrices A, B for which AB and BA are defined. For instance, if A equal to 1, 0, 0, 2, B equal to 3, 0, 0, 4, then AB equal to BA equal to 3, 0, 0, 8. Observe that multiplication of diagonal matrices of same order will be commutative.
Zero matrix as the product of two non-zero matrices. We know that for real numbers A, B, if AB is equal to 0, then either A is equal to 0 or B is equal to 0. This need not be true for matrices. We will observe this through an example.
Find AB if A is equal to matrix 0, minus 1, 0, 2 and B is equal to matrix 3, 5, 0, 0. Solution. We have AB is equal to matrix 0, minus 1, 0, 2 into matrix 3, 5, 0, 0 is equal to matrix 0, 0, 0, 0. Thus, if the product of two matrices is a zero matrix, it is not necessary that one of the matrices is a zero matrix.
Properties of multiplication of matrices. The multiplication of matrices possesses the following properties, which we state without proof. 1. The associative law. For any three matrices A, B, and C, we have AB into C is equal to A into BC, whenever both sides of the equality are defined. 2. The distributive law. For three matrices A, B, and C, 1. A into B plus C is equal to AB plus AC, and 2. A plus B the whole into C is equal to AC plus BC, whenever both sides of equality are defined. And 3. The existence of multiplicative identity. For every square matrix A, there exists an identity matrix of same order such that IA is equal to AI is equal to A.
If matrix A, B and C are given as shown, find A into BC, AB into C and show that AB into C is equal to A into BC. Solution. We have AB is equal to matrix 1, 1, minus 1, 2, 0, 3, 3, minus 1, 2 into matrix 1, 3, 0, 2, minus 1, 4 is equal to matrix 2, 1, minus 1, 18, 1, 15. AB into C is equal to matrix 2, 1, minus 1, 18, 1, 15 into matrix 1, 2, 3, minus 4, 2, 0, minus 2, 1 is equal to matrix 4, 4, 4, minus 7, 35, minus 2, minus 39, 22, 31, 2, minus 27, 11. Now, BC is equal to matrix 1, 3, 0, 2, minus 1, 4 into matrix 1, 2, 3, minus 4, 2, 0, minus 2, 1 is equal to matrix 7, 2, minus 3, minus 1, 4, 0, minus 4, 2, 7 minus 2 minus 11, 8. Therefore, A into BC is equal to matrix 1, 1 minus 1, 2, 0, 3, 3 minus 1, 2 into matrix 7, 2 minus 3 minus 1, 4, 0 minus 4, 2, 7 minus 2 minus 11, 8 is equal to matrix 4, 4, 4 minus 7, 35 minus 2 minus 39, 22, 31, 2 minus 27, 11. Clearly, AB into C is equal to A into BC.
Example: in a legislative assembly election, a political group hired a public relations firm to promote its candidate in 3 ways: telephone, house calls, and letters. The post per contact in paise is given in matrix A as cost per contact. The number of contacts of each type made in 2 cities X and Y is given below. Find the total amount spent by the group in the 2 cities X and Y. Solution: we have BA equal to 40,000 plus 50,000 plus 2,50,000 tends to X, 1,20,000 plus 10 lakh plus 50 lakh tends to Y equal to 3,40,000 tends to X, 7,20,000 tends to Y. So, the total amount spent by the group in the 2 cities is 3,40,000 pies and 7,20,000 pies, that is rupees 3,400 and rupees 7,200 respectively. Transpose of a matrix. In this section, we shall learn about transpose of a matrix and special types of matrices such as symmetric and skew symmetric matrices. Properties of transpose of the matrices. For any matrices A and B of suitable orders, we have A dash whole dash equal to A, Ka whole dash equal to Ka dash, where K is any constant. A plus B whole dash equal to A dash plus B dash. AB whole dash equal to B dash A dash.
If A is equal to matrix 3, root 3, 2, 4, 2, 0 and B is equal to matrix 2, minus 1, 2, 1, 2, 4. Verify that A dash of whole dash is equal to A plus B whole dash is equal to A dash plus B dash. KB whole dash is equal to KB dash, where K is any constant. Solution. Subdivision 1. We have A is equal to matrix 3, root 3, 2, 4, 2, 0 implies A dash is equal to matrix 3, 4, root 3, 2, 2, 0 implies A dash whole dash is equal to matrix 3, root 3, 2, 4, 2, 0 is equal to A. Thus, A dash whole dash is equal to A. Subdivision 2. We have A is equal to matrix 3, root 3, 2, 4, 2, 0. B is equal to matrix 2, minus 1, 2, 1, 2, 4 implies A plus B is equal to matrix 5, root 3 minus 1, 4, 5, 4, 4. Therefore, A plus B whole dash is equal to matrix 5, 5, root 3 minus 1, 4, 4, 4. Now, A is equal to matrix 3, 4, root 3, 2, 2, 0. B dash is equal to matrix 2, 1, minus 1, 2, 2, 4. So, A dash plus B dash is equal to matrix 5, 5, Root 3 minus 1, 4, 4, 4. Thus, a plus b whole dash is equal to a dash plus b dash. Subdivision 3. We have kb is equal to k into matrix 2, minus 1, 2, 1, 2, 4 is equal to matrix 2k minus k, 2k, k, 2k, 4k. Then kb whole dash is equal to matrix 2k, k, minus k, 2k, 2k, 4k is equal to k into matrix 2, 1, minus 1, 2, 2, 4 is equal to kb dash. Thus, kb whole dash is equal to kb dash.
Symmetric and skew symmetric matrices. Definition: a square matrix A is equal to matrix of Aij is said to be symmetric if A dash is equal to A. That is, matrix of Aij is equal to matrix of Aij for all possible values of I and j. Definition: a square matrix A is equal to matrix of Aij is said to be skew symmetric matrix if A dash is equal to minus A, that is, Aij is equal to minus Aij for all possible values of I and j. Now, if we put I is equal to j, we have Aii is equal to minus Aii. Therefore, 2Aii is equal to 0, or Aii is equal to 0 for all i's. This means that all the diagonal elements of a skew-symmetric matrix are 0. Transformation of a matrix. There are 6 operations or transformations on a matrix, 3 of which are due to rows and 3 due to columns, which are known as elementary operations or transformations.